This will be part two of 8.EE.1, properties of integers and exponents. We're going to talk a lot about negative exponents and zero exponents. And it goes along with chapter 4.6.
All right, so here we go again. We're going to talk about chapter 4.6. So this is going to deal with zero and negative exponents. So yesterday we talked about just what exponents are and some of the rules that exponents have. Today we're going to talk about what happens when you have a zero or a negative exponent. And I just want you to bear with me here. I want you to just practice as best as you can. And I'm hoping that you'll get a general idea here. A lot of it is just going to take some practice and just some effort, some opening your mind up a little bit to to this topic. It's fine to make mistakes. Many of you are going to make lots of mistakes here. We're going to do lots of practice so that you have an opportunity to make lots of mistakes and hopefully figure it out. So the first thing I want you to do is just relax. We will work through this together, okay? I know I haven't been here. I wasn't here today, and I wasn't here yesterday. Don't worry, I'm not going to give you a quiz the day I come back. We'll take a look at both these assignments and work through any of the questions that you have, okay? All right, so let's start talking about this. The first thing we want to do here is when we're talking about zero and negative exponents is let's just review what an exponent actually means, okay? So an exponent is repeated multiplication, right? So let's do this. Let's go ahead and let's just take a simple exponent here. So let's say we'll do 5 squared, okay? Well, 5 squared is going to be equal to 25, okay? And let's say I do 5 cubed, right? Well, here, let's do this. Let me adjust this. So we have 5 squared, okay? That's going to be equal to, that's actually equal to 5. No, I don't want to update Java. 5 times 5, okay? Which that is equal to 25, okay? Then we have 5 cubed. That's equal to 5 times 5 times 5. And this one is equal to, well, it's 25 times 5, which is 125. Okay, well then let's go ahead and what happens if we have 5 to the 4th? Okay, well that's going to be 5 times 5 times 5 times 5, which is equal to 625. Okay, now what I want you to do is we're going to pause the video here for a second, and I want you to tell me, what do you think? Okay, I want you to talk with your people around you, and I want you to come up with, first, what do you think this is going to be equal to? Okay, and then notice, look at, see if you can devise some kind of pattern here. All right, and then I want you to say, okay, well, what's going to happen if we do that? Okay, so why don't you go ahead and pause the video and tell me, or talk with the people around you, what you think is going to happen. Take maybe a minute to 2 minutes. All right, go. All right, hopefully you had a chance to discuss with your neighbors. And when you did 5 to the first power, okay, hopefully what you saw is this tells you the number of 5s that you would write, right? This tells you the number of 5s you would write. 3, so I write 3 and multiply them. This says 4, I've multiplied 4 of them. So if I have 1, I'm just going to have 1 5, and that's going to be equal to 5. Okay. Well, what is 5 to the 0 going to come out to? Now, I'm assuming that many of you guys would all have sort of the same thought process here. I'm guessing that almost all of you came up with one of two answers. You either thought that it equals 0, or maybe some of you thought it might be equal to 1. Okay. Now, looking at these numbers here, and looking at what happens to the numbers, I want you to pause the video again, and I want you to see if you can come up with a pattern. See if you can make or justify or convince the people around you as to if it's either 0 or if it's 1. Okay, take 1 minute. Pause the video now. Okay, so I'm hoping what you saw is as you go up, right, you repeatedly add another 5, right? We start at 5, we multiply by itself again, and then we multiply it by itself again, and we multiply by itself again. Well, what happens when you go backwards, right? We know that as the exponent climbs, we add another 5, okay? We multiply by 5 again. Well, what happens when you go down? What happens when you reverse this? If you start at 4, that's 5 times 5 times 5 times 5. Well, what if I drop down a 3? that's getting rid of a 5, okay? Well, let's think about what does that mean? Am I subtracting 5? What am I doing there? Hopefully you're looking at it and you go, oh, wait a second, we're dividing by 5. So as I go down here, right, as my exponent goes from 3 to 2, I have divided by 5 again. I've removed a 5, right? Instead of repeatedly multiplying, I'm going to divide. So as this exponent goes up, I multiply more. As the exponent goes down, I multiply less, which is like dividing. So then if you have 5 to the first power, that's 5. And what's going to happen here is 5 to the 0 power is actually 1. So now, as you do that, what I want you to look at is what is now going to happen if I keep going down, okay? If I keep going, right, 4 minus 1, 3, minus 1 is 2, minus 1 is 1, minus 1 is 0, minus 1, now I have a negative exponent, okay? And a lot of times this is where people, their brains explode. They start going, what? Negative exponent? That's crazy. What am I supposed to do with that? That doesn't make any sense. It actually makes a whole lot of sense if you let your brain really sort of absorb what's happening here, okay? Think about it. Let's say, find the pattern here, okay? All of these are continuing on a pattern, all right? So the next thing I want you to do is pause the video here, and I want you to talk to your partners about what do you think is going to happen here. What's going to happen when we have 5 to the negative 1 power and 5 to the negative 2 power, okay? So let's go ahead and why don't you take a look and pause the video. I do that now. All right. Well, if you were listening and you paid attention that you saw that this keeps dividing by 5, okay? Well, let's do this. I bet a bunch of you came up with, you said, I bet there was probably a pretty decent debate between people saying it was like negative 5 or maybe 1/5 or maybe, let's see, negative 1. I could see all of those. And there's probably some other ones. But if you follow the pattern, remember this is divide by 5, divide by 5, divide by 5, divide by 5. So 1 divided by 5 is actually 1/5. Okay? So it's not this and it's not that. Okay? Because remember, the base here is just 5. It's 5. And so instead of multiplying, this says take 5 and multiply it once. So you have 5. This says take 5 and multiply it twice. So you have here. Well, the negative, right, that's the opposite. So we're not multiplying by 5. We are actually going to do, think about it, what's the opposite of multiplying? That's right, it's divide. So we are going to divide by 5. And you might ask yourself, where does this 1 come from? Right? Where does the 1... Sorry, I got a sick daughter who's waking up from a nap. So you ask yourself, where does that 1 come from? Well, this has to be something, okay? It has to be something. We're not dealing with 0. It's not nothing, okay? If it was 0 on top, then this would be 0, and it would sort of end the story. All right? So then I'm hoping what you see now is this is 5 to the negative 2nd power is actually, right? You're going to divide by 5 twice. So this actually turns into 1 over 25, okay? Because basically this comes down to 1 over 5 squared, okay? And right here, this would have been a 1. So you'll notice what happens is that negative drops the base down into the denominator, okay? Because all things denominator are dividing, right? We're dividing it up. We're cutting it into this many pieces, right? The top number is multiplication. So the top numbers we multiply, these bottom numbers we divide, which is why this says take 5 and divide it, right? Go the opposite. Don't multiply over and over again. Divide twice. So divide it by 5 and divide by 5 again, and you end up with 1 over 25. Okay? So you're going to have to let that sink in a little bit. Don't expect to just understand that immediately the first time. It's not the easiest thing. If you do get it, that's great. I applaud you. If you don't, that's totally natural. It's a natural phenomenon. This is not an easy thing to wrap your head around. Okay, so let's take a look at this. What I want you to do is I want you to think about this. Here's 3 to the negative second power, and let's see what this means. Now, again, this is mathematics. It's a language. I ask that when you do these things, you try to read them. You ask yourself, what is this thing actually saying? Okay. Well, what this is saying is I have this number 3, and what I'm going to do with it is I'm going to repeatedly divide it by 2. Okay. Right now it says it's a base of 3. This tells me I'm going to divide it twice. Okay. So what I'm going to do here is I'm going to pop in a division bar. Okay. And then what happens is, all right, and I'm going to show you this visually, is when I take this, it's right now it's in the numerator, right? This is all things multiply up on top. When I take it down, right, or when I want to make it dividing, I drop it down into the denominator, and now I have 3 squared, but it's in dividing. Okay, so I'm going to pop in a 1 up here because I can't make that equal to 0. And so then what is 3 squared? Well, that's 9. So I get 1 over 9. Okay, so let's take a look at that again. When it was 3 to the negative second power, right? Or notice right now it's 3 squared in the denominator. In fact, here you go. If it's 1 over 3 squared, I can write that as 3 to the negative second power. Okay? They're all saying the same thing. These are all equivalent expressions. Drop it down, and I get 1 over 3 squared, which is equal to 1/9. Okay? Let's do that one more time. You'll notice as I grab it, if it's up in the denominator, it has a negative exponent. I drop it. I'm sorry, if it's up in the numerator and has a negative exponent, I drop it down in the denominator, and now the exponent becomes positive. Notice I put it into the opposite location. Right? It was in the numerator. It was negative. I move it into the opposite place, into the denominator, and this becomes positive. All right. Well, let's take a look at a little bit tougher of example. Here's one. I have 3 cubed times 3 to the negative 7th power. A couple ways we can do this. First, let's go ahead and visualize this. Okay. First, if I make this a fraction bar, what I can do is I can say, well, this 3, that means 3 multiplied by 3 times. Okay, so then I'm going to do the, 3 times 3 times 3, 3 cubed. Well, this is divide by 7, or divide 3 7 times. So I'm going to drop that down into the denominator. Okay, now this is going to be equal to, 3 times 3 times 3 all over 3 times 3 times 3 times 3 times 3 times 3 times 3. I get it? 1, 2, 3, 4, 5, 6, 7. Okay. That becomes 1. That becomes 1. That becomes 1. And I'm left with 1 over 3 to the 4th power, which can be written as, right, if this is, it says divide by 3 4 times, I can write that as 3 to the negative 4th power. Now, another way I could have done this is, okay, let's do this. We'll just reset the page. Okay, now another way I could have done this, whoops, is I could have said, okay, this has the same base. I'm multiplying, so my rules of exponents say that I can just add the exponents, right? 3, and then this would be 3 plus a negative 7. That's going to be equal to 3 to the negative 4th. Same thing, which is equal to 1 over 3 to the 4th, because I'm dividing by 3 4 times. Okay, I can only talk about this so much. It's got to be, I think it's better if you guys see some of these. I'm going to give you one other quick example. Sometimes you'll see a fraction, right? It's inside these parentheses. This whole thing is to the negative 2nd power. Okay, again, this means divide. All right, so if you are dividing, all right, we're sort of doing opposite of everything in here. So divide by 3/4. Okay, now if you remember how to divide by fractions, you multiply by the reciprocal. But let me just show you a nice little easy trick here. Okay, since this is a negative, it means anything that's in the numerator goes to the denominator. Anything in the denominator goes to the numerator. So what I'm going to do here is I'm going to go ahead and flip it. Okay, notice what happened there, right? Here it is, 3/4 to the negative 2nd power. Okay, I'm going to change this to positive. So when I change this to positive, everything flips. I use up that negative, okay? And then from here, this is the same as saying 4/3 times 4/3, which is equal to 16/9. All right. Well, hopefully you have a decent idea on how to do this. Again, it takes a lot of practice, and that's what you're going to have time to do right now. So go ahead and you have the rest of the class period to work on these. If you don't finish, please finish it at home. Make sure you check your answers. All right, check your answers, check your answers, check your answers. There's not necessarily a whole lot of work you can show on these. Again, it's just going to be about, do you understand it? Can you rewrite it? Are you understanding that negative exponents mean divide and positive exponents mean multiply? All right, have fun. Don't get too frustrated, and I will see you guys tomorrow.